Hello, listeners. This is the Risky Planner Podcast. Thanks for tuning in. Hey, Albert. How you doing?
Hey, Nate. Doing all right. How are you?
As always, it's been a minute. I feel like we've both been really busy on stuff.
We have, yeah.
Good to connect.
It is always very good.
Yeah.
It was fun to build this. I know I'm jumping ahead a little bit, but it was fun to build this outline.
It's really interesting, and I'm going to nerd out and, just read in some of the background material, getting prepped. It's really interesting.
Yeah, it is.
If you like data, if you like cool technology, like this is the episode for you.
Hey, not that the other ones weren't also that, but hey.
Yes.
This one especially.
So when I was preparing for this, knowing that we were going to talk about twins...
Sure.
There's this thing, like every Nate I have ever met, every time they introduce themselves as Nate, people say Dave to clarify. Every Nate I have ever met has confirmed that this happens to them. I have never met a Nate that did not get Dave as a response.
Wait, how do you get from Nate to Dave?
I have no idea, but it's like a conspiracy theory.
Nate, you're blowing my mind here. Like this can't be true. Like what you're saying is too absurd.
And ask
I am asking a Nate.
When you introduce yourself, and the person responds to clarify your name,
you're gonna get Dave.
Do they say Dave? And every Nate I've ever met says yes.
That's absurd. That's insanity. Like,
it is absurd. It makes me question reality. That is the Matrix hiccuping.
Do you think that Nates and Daves are frequently twin names? Like how many Nates who have a twin, is their twin named Dave?
I don't know if I've ever met a Nate that has a twin.
But you have met Nates who are ostensibly named Dave, which is fun.
That I have. And it's
my version
wild.
of that is Alfred for Albert. People really want to call me Alfred.
Really?
Which was so that
Alberto?
problem got.
That's the best.
Alberto, people who actually know me well might call me Alberto. And also people who don't know me very well but are Italian or Spanish. That also happens.
Excellent.
But no, the Alfred thing it really took off when the Christopher Nolan Batman movies became a thing. Because Alfred was on the tip of everyone's tongue again, thanks to Michael Caine and I guess Christopher Nolan. But yeah, so I got to be Alfred for a few years there.
But I look like a Dave. Let's jump into it because I think we've kept people waiting long enough. We're going to talk about digital twins. We're going to talk about BIM, digital twins, right?
We are.
I think, before we get into it, I just want you to, a lot of our audience has heard the term. I think, can you just sort of level set with us? What is it? What's a digital twin?
What is a BIM and what is a digital twin?
Yeah, just define some key terms before we get to
the
discussion.
Bet. I mean, it's worth mentioning also that we're going to put both of those terms in the episode title, and they do mean different things, but it's kind of it's at a certain point it's a distinction without a difference. And we're also going to talk about convergent technologies, and that's part of the reason why it's all this stuff is kind of coming together. But anyway, so what is BIM? We've talked about BIM a little bit on previous episodes, and I've defined it there. But for the benefit of this episode, building information modeling or building information management, depending on who you talk to. That can mean and does mean a very wide swath of different technologies that all kind of serve a related function of storing information about a built asset. The traditional use case for building information modeling is for operating and maintaining an existing building. So you might your building information management system might have a stack of as-built drawings from the project that are all tied to, say, for example, the equipment list for the project. And by the way, when I say project, I'm using project to mean the built asset itself, like the thing that was constructed. The upshot is that you can take a lot of different kinds of information about a building and sort of jam them together in a way that makes all that information more usable. So
it's digital. Are we talking about digital or are we talking about something?
Well, these days, definitely. I mean, there's no efficient way to maintain, especially for a new building, all that information in traditional dead leaves format. But of course, that's how it was done for the longest of times.
Yep.
that could literally mean anything. Building information management could mean that you're managing any kind of information about a building. That often usually includes a set of drawings, usually includes some information about what's in those drawings, like the equipment list, the major valves and pipes and that sort of thing. Where people are meant to go, where people
Wires.
are not meant to go. Like,
Yep.
yeah, exactly. Like cabling, traceways, and that sort of thing. In BIM speak, you can have different levels or maturity levels of BIM that are described in dimensions. And for 2 dimensions and 3 dimensions, they mean just what you think they do. Like those drawings that I mentioned are in 2 dimensions for a 2D BIM model, 3 dimensions for a 3D BIM model. But where it gets really interesting is that you get 4, 5, and 6D BIM as well.
I mean, we talked about Christopher Nolan, right? Like back before in the opening. I mean, here we are talking about 4D, 5D, 6D.
Yeah,
like,
we're 4D. Yeah, it's 4D Inception BIM.
Yeah, that's what I was. Yeah, I'm 3 dreams deep.
I don't know. Anyway, that's not the point. The point is that with a 4D BIM model, you're taking all that 3D information, like that 3D model of say, of a building, and attaching it to a schedule. So then you can start to see the building come together. So like you tie particular milestones or even schedule activities to the elements in the design package, the 3D design package, that are coming up as part of that activity. So that's your 4D model.
But we don't call that a tesseract. How does the digital twin? So you've talked about BIM. How does the digital twin differ from BIM? BIM sounds like a catch-all. Sounds like a lot of things. What is the digital twin now? So
if you are building a 4D BIM model, all that means is that you have a 3D model that now progresses through time. So that could mean that your 3D model is very complete, or it could mean that it is just enough to get you the result that you're looking for. Like, say, for example, if you're responsible for building the core and shell of a new apartment complex, you may not model the interiors of the building. You may only model the structural, mechanical, electrical, plumbing, curtain wall, facade, like groundworks, like the stuff that would matter to the general building contractor. They might mate all those to their construction schedule in order to achieve some savings. And there are savings to be achieved there. But that's just BIM. So the BIM model might get handed over to an operations and maintenance group that chooses to flesh out all that 3D, construction data with the full-blown interiors package, like placing chairs in places. And even you might go as detailed as putting like the bone stock spec decorations in place, to show like that there's a painting here, or we're going to have like there's a heating register over there, so we can't put a sofa, that kind of thing. So they'll build the 3D model out to a degree of detail and precision that you actually have created a literal digital twin of the physical object in a virtual environment, so that you can play with stuff. So a 3D BIM model that has a lot of detail, that's basically what a digital twin is.
So it's all very interesting. Why are you interested in it?
Well,
where did that
for
start?
2 reasons.
Yeah.
I mean, one, you mentioned at the top that this is just a fun topic for geeking out on, because it's really kind of nuts to conceptualize. Like, it's really cool. It's really heady, and like we live in an era where everything is, as U.S. President Donald Trump would say, it's all computer. It's
Quotable
all computer.
quotes.
Exactly.
It's going on the podcast quote board. It's all computer.
It's all computer.
I love it.
And it is all computer.
It truly is. Every day. It's like, we talk about AI in another episode and its impact on just project management, capital projects. It's moving at light speed, right? Like every day, every week. I mean, it's changing.
And that's it.
Constantly.
That's it, right? So that's reason one, right? As a project professional, I need to keep abreast of the developments in this kind of technological space, and make sure that when I'm bringing advice to my clients, which is what I'm paid for ostensibly, is to provide good advice, it needs to be not just good but also timely. So we live in an era where this kind of technology, the digital twin and BIM technology, is very much on the upswing, and this is the second reason why. Is like I recently ran across some research that indicates that the digital twin market is growing significantly faster, like almost twice as fast when compared to the architectural, engineering, and construction market generally.
Really? So, why is that market? What's driving that?
Faster growth means adoption.
Yeah. Albert, why are these technologies getting adopted?
Well, there's two big reasons. One is pressure from, well, pressure is the wrong word, but incentives from governments and other kinds of pseudo-governmental agencies that try to push for new technology adoption, either through tax credits or direct subsidy or that kind of thing. That's one reason, but the real reason is number two, which is that there are actual benefits to doing this. I mean, it's long been true that if you could do a 3D model for your thing, then you probably should, because it's helpful for design development and clash detection and change control and things like that. So layering on more stuff to that 3D model is a logical progression that seems to have some pretty real benefits. So we'll get into some of the details about the benefits, I think, a little later. But that's why they're starting to really take off, and it wouldn't surprise me too much if the report I was referencing earlier has us spending as a species $155 billion on building digital twins in the year 2030. That's based on their projection from 2025. So it's pretty recent research, and that's a big number. I mean, considering that design probably certainly costs less than 10% on your average project. Okay. Generally, around 5%. So you split that up, imagining that it's 5% of a whole bunch of different projects. That's a lot of projects being covered by BIM documentation.
Yep. Dokanish and Company is all about optimizing, integrating, connecting the front lines with what's happening with reporting, scheduling, all the data, right? Like we're optimizing, people, process, technology, and data. So my question is, on a building, on a project, like the carpenter and the superintendent still need to get work done, right? Like they still need to do what they need to do every day. How do you make sure that an advanced system like you're talking about is actually useful for these frontline workers that are making the project happen?
Well, it's a really excellent question, because you can, I mean, if you've ever been on a construction site, then you've found, either by accident or on purpose, their big book of drawings. They usually have a big flat pack, extremely crudely bound set of large size drawings. They'll be the size of your entire upper body, sitting on a podium somewhere, so that the construction superintendents and the tradespeople can go take a look at it and drive the work. And let me tell you, when you're printing on a piece of paper, it's hard to do that in 3D. So the answers to your question are two things. Like, one, the new models and the new systems need to service existing means of work, right? Like, there are going to be places where the big book of drawings is still what they expect to see when they walk onto a job site. They're going to still want to have the big book of 2D, because like the plans, especially for say an interior construction build in like commercial and residential space, the plan view, the 2D view, is really useful. I mean, it's what you need, right? Like you're placing things at elevation, you get the elevation view. You're placing things within a rectangular space, you get the big rectangular plan view. It's not difficult to understand why that would be the primary tool for doing field design and construction management work. So, in addition to being able to service those existing demands, you need to give new tools to the people so that they can access those enhanced features. Because the reason why I say this is such a good question is because the rubber meets the road on a construction project where the stuff is actually getting built. So if you want to realize cost savings, and especially if you want to realize schedule savings, you really have to start there. You have to think about how it's going to benefit those people doing the work. And like the obvious answer to that has nothing to do with the people actually in the field is that the information that you give them, regardless of the format you're giving them in, will theoretically be of a higher quality because it has been more battle tested. And that's really the purpose of building a digital twin in the first place, is because if you build an actual twin of your building, then you've done the entire construction project. And if you did it for the purpose of figuring out in what ways the structure might fail or how it might be difficult to construct, then you have to do the whole thing in order to validate that the whole thing was doable. Do you know what I mean?
Yep.
If you do it digitally, you can do it at a fraction of the cost, and you can build incredibly complex versions of projects that have lots of levers you can pull and buttons you can press to change features about it, like test it for things like structural loading, failure analyses, earthquake. But even for something as simple as like, will I be able to get a couch up the stairs when it's built? Like that kind of stuff. It goes from the mega scale, like will it survive a fire in the building next door, all the way down to is this going to be a pleasant place for tenants to move into and out of? Mm-hmm. Like it covers the gamut at a fraction of the cost. And if you do all that work up front, then you will have completed a plan that is significantly more robust and thorough than if you were just doing it with a 2D set of drawings. So even if all you ever provide to the people in the field is the traditional paper printouts of their construction schedule and paper printouts of their drawings, those two things will both be so much better, again, in principle, that the work they do will be, consummately better as well. So
yeah, I get it. It's the really, it's about enabling everyone that's involved with the project on down. So when you are getting it done, I don't know what I'm saying.
And that's the best version. No, I mean you're saying the right thing.
Yeah,
like because when it comes down to brass tacks, like you can provide them with the same old toys, or you can empower them with some of the new toys too. So like even if the 2D drawings would be better, like imagine if they had some way of accessing the full 3D model so that they could look at things, because like ceiling space gets very, very crowded. Like anything overhead, if you look up any place, you're either going to see a flat surface, which is just covering up all the nonsense that's going on above it, or you're actually going to see the nonsense. Yep. And if you've seen the nonsense, if you've been to like a trendy pizza restaurant with an open ceiling or whatever, there's all kinds of pipes and electrical and crap and lighting and whatnot that's all sharing the same vertical.
Yep.
And let me tell you, a bunch of that stuff in that trendy pizza restaurant was probably somebody's nightmare for a few weeks because they likely had drawings that showed wire running straight through HVAC equipment.
But I hope they got some of that pizza. So the data integration. So when you talk about this, and we talked about empowering frontline workers, empowering the team, empowering superintendents, you answered my question about carpenter and superintendents.
Sure.
So now let's talk about put ourselves back in the shoes of the project manager. The data integration for the digital twin is complex. And one of our specialties is organizational change management. So ensuring that new tools don't gather dust, but they are applied and you're maximizing value. How do you prevent a digital twin, the technology from becoming an expensive, digital paperweight, so to speak?
Yeah. No, that the answer is exactly what you said, right? That it needs to be a comprehensive cultural change that redefines how projects get planned, and that's the easiest place to start because it's something that can be done by fiat. In other words, if you are a project director or a project executive, and you want to allocate budget on your project to building a digital twin and 5 or 6D BIM models, which we didn't talk about, by the way. We should probably talk about what those are. If you want to allocate that money, and if you think you can justify it to your betters and get the funds appropriated thusly, then you get to decide that you're doing planning this way. So that's the easiest change to make, is just deciding that you're going to fund it and declaring from your ivory tower that it's going to happen. But actually building workflows and processes around it that aren't saddled by the cruft of the old way of doing things is a real challenge and probably requires a little bit of learning from mistakes to do right. So if your design organization, your design contractor is accustomed to working in 2D space or in a more simplified 3D space, or that this is the other thing too. If you want to build a true digital twin, you have to model everything. A lot of stuff in your average construction project doesn't actually get drawn or modeled. It gets field run. And that does make some sense.
What does that mean?
Field running is, it's basically doing the engine. It's building the plane while you fly it. So if you're out there on a construction site and you have detailed comprehensive drawings for where all, say, the duct work goes, because duct work is big. So especially like the ring main duct for a floor of an office building is going to be a pretty beefy piece of sheet metal. So it's going to take up a lot of space. It's cheap, it's easy to install, but it's large. So that means it has to be modeled. So when you model it, you're going to model it alongside other things that are kind of, quote unquote, immovable objects, things like the sprinkler piping. But you know what can be moved pretty much as it needs to be? The electrical conduit. Because electricity doesn't really care how many twisty, bendy turns and things it has. So you would model things that absolutely must be straight or take up a lot of space, like your sprinkler piping and your duct work. And then you wouldn't model things that you can just kind of spaghetti around it, right?
Right.
Well, to do a digital twin properly, you do have to model those things. So here's the thing. That sprinkler pipe I talked about, it needs to be long and straight as it can be for sprinkler pipe reasons. Right? It needs to maintain a constant pressure. Like when the sprinklers turn on, it actually needs to be, the water should come out, just spitball in here. But it turns out that when you build pipes that are predominantly quite long and quite straight, you're cutting down on labor. You don't have to cut the pipe as frequently. You're cutting down on material cost because elbows and T-junctions and 45s and that sort of thing, they're more expensive than the pipe is. It cuts down on the headache associated to the next person who has to come in and field run something. Because let's say you've got a new electrical conduit that goes in with 1590s to get around all of the duct work and stuff that's already in the way there. And then the next person comes and they have to install control wire for the HVAC terminal units. Mm-hmm. Well, okay, so now not only is there a duct and a sprinkler pipe in the way, there's also this spaghetti pipe conduit that's carrying electrical. And by the way, you as the control systems person, you might have to then run your own conduit because you didn't get to use the same conduit run as the electrician did because none of it was planned in advance. So, on the one hand, it feels cheaper and it often is cheaper to just let people in the field just go do whatever works and not you think about it too hard. But on the other hand, if you do the planning in advance and you do it properly, you can actually save a lot of time and money. And, it's death by 1,000 cuts if you don't do that, right?
Yeah.
Like all those little tiny decisions add up.
So I do want to plug, we just did a webinar about organizational change management, cultural change, with regard to new technologies with our colleague Omar Kaoud. And we will make sure that link is in the show notes, but it's all about how to sort of start that process. So I just want to plug that real quick.
He talks a bit about managing change resistance in that webinar too.
He does,
right?
Yeah, and I think that's also planned for a future webinar because we're going to dive into it a little bit more. There's a white paper that we published on change resistance that we'll also include in the show notes as well. So thanks for bringing that up.
No, for sure. Because honestly, if there's one thing that could sink a BIM implementation, if it includes the full blown digital twin stuff and the creation of 3D models for electrical conduit and control system wiring and that sort of thing, a lot of people are going to push back against that because it feels inefficient to them, naturally, like intuitively. They're inclined to believe that it's going to be less efficient, even if it isn't. So that's change resistance in a nutshell, and you're going to get a lot of that when you're building your first digital twin. Yeah,
absolutely. Go back to what BIM, like we talked about 3D, 2D, and 3D, but you mentioned 5D, right? Let's go back to that. Let's talk about what that is. Tell me what that is and why it's important.
So by way of reminder, 2D, traditional, flat drawings. 3D is obviously adding that third dimension. 4D is mating that up with your schedule. So 4-dimension, and its changes over time. 5D is when you add in your cost information. So if you have your WBS set up properly, and which is also a service we provide, and you have your systems set up to consume that WBS, like say you've got your design documentation, your work packages are using the same WBS as your schedule and your cost breakdown, then you can take all those information and kind of smush them together into a consolidated view that doesn't just show your model changing over time, but how much it's going to cost over time. So you can predict spikes in effort, spikes in cost, potential gaps in funding, times when you'll need to do a little bit more to economize, like if your workforce isn't available. So basically anything that would go into your cost estimate becomes surfaced as part of your schedule and alongside the design. So you can watch the whole thing evolve in accelerated time.
That's cool.
And really do. It's very cool.
Yeah, that's cool.
I've seen it. If you look on LinkedIn, you're going to see like animated GIFs of 5D BIM models. From time. I love those. I will simply stare at those for longer than is warranted.
I do appreciate that you pronounce GIF correctly.
Right? Yeah, man. The guy who invented GIFs says they're named GIFs, and he's wrong.
Yeah, he's wrong.
So,
you heard it here first.
He's absolutely. You definitely didn't hear it here first, but you did hear it here.
Tell me about convergent technologies. Like, what are they? with regard to the topic of this episode?
Convergent technology is a general term that just means that a lot of different technologies are sort of pointing in the same direction. We're trying to solve the same problems. So in the case of digital twins, an obvious example of a convergent technology would be virtual reality. Mm-hmm. So if you put on a virtual reality headset and you've got a digital twin model that can be read by whatever headset, program you're using, that was made me sound like the world's oldest man, but you get the idea. Then you can walk around your planned physical asset in virtual space and play with stuff and see.
I mean,
how
you're
it
taking me
looks.
back to 2023, right? This is all metaverse,
All
but
the
it
way
really
back
is.
to-
I mean, it is truly an application for this. So VR and digital.
It totally
twinning
is.
Makes sense.
And like I was in Dubai not too long ago for a mega project that includes an ultra luxury real estate development, and you bet they were going to use VR and a digital twin to sell those spaces to their ultra high end customers. They were going to use the Apple Vision Pro, by the way. So, Apple VR stuff is very cool and it works extremely well, but it's hardly the only game in town. Like there's VR applications that are for desktop application type stuff. Like, how to use Windows better with AR. Like Microsoft had a whole feature offering around that for a while. There's some that are specific for video gaming. There's some that are specific for architecture and engineering, where it's just for finding clash detection and doing efficient routing and things like that. But they're all pointed in the same direction of put thing on face, walk around virtual environment. So that's a good, simple example of what's meant by a convergent technology. But there's more, right?
Yeah.
Like, how do you build the digital twin? Well, you could pay jillions of people to sit in front of computers with mice on 2D screens attempting to interact with 3D models, and that's always going to be a less efficient exercise than having 2D screens to build 2D models. Or you can start on third base by capturing the space in real 3D using scanning technology.
But you got to get to third base first. So what are you using to capture?
Well, I mean, this is we talk a little bit about design one, build many as a concept.
Yep.
If you have a thing that you're trying to reproduce, or if you have something that is a known good configuration, you can scan it and treat that as like a first draft of your design. But there are other things that's useful for too. So even if you designed the whole thing on desktop, and you didn't have the advent of a 3D scan to start from, once the thing starts to get built, you can still run a robot through there with a 3D scanning rig on it.
A robot, something.
Yeah, exactly. So some kind of, it doesn't even have to be automated. Like you can remote pilot a drone through there and just have it, hang out and take 3D scans of an environment that's under construction to see how the in progress version compares to the designed version. If there are any deviations, it can flag them automatically and let people know. And there are whole systems being built, like software systems, to contain and compare all of this, like all of these data, like the in progress data. Because it used to be that when you're dealing with an asset that's under construction, you get some field markups during construction, but mostly what you get is the design documentation and then the as-built. So here's what you gave us, and then here's what we did. Being able to generate without hugely impacting the labor, that's actually on site, being able to generate that in real time as the project progresses is hugely valuable. Because you can detect changes early. You can detect deviations early. Like, oh no, you guys put that wall in the wrong place.
Right.
Like, we're going to have issues with fitting the material into this space because that wall is a centimeter away from where it should be. And like, if you walk in by eye with a clipboard, you're likely not going to notice if a wall is off by a centimeter. So the choice is do an expensive solution later or do a cheap solution now. So that 3D scanning stuff is a really powerful value add to like an in construction, an in-flight asset that's being built.
That's good. Like, how do you? It sounds great. All of this technology, cool. How do you prevent, all of these, different pieces of technology and inputs and analyses and whatnot from, just kind of becoming a circus of cool, shiny objects versus solving real problems, right? Like, it's easy for us to talk about it.
It should be tight and well controlled and well integrated. If you're doing digital twinning and you're trying to mate that up with like a 4 or 5 or even 60, by the way, when you're doing 60 BIM, that brings in the operations and maintenance information. So in addition to the project cost and schedule, you're now also seeing the like the maintenance schedules of things and planned replacements. You can use it to plan out like capital work for the next 10, 20, 50 years. So that adds a whole extra layer of power to it, but also adds a layer of complexity because like the operational systems are probably going to be different from the project systems that were put in to build the thing in the first place. So it could very easily become a technology circus. You could wind up with things just kind of happening because they're cool or because somebody got a pitch from a software company on the right day. So as with building things in general, the answer to this problem is that it has to be planned thoroughly.
Yeah.
It has to be thought through in its totality. Like you have to, to quote the 7 Habits of Highly Effective People, you have to begin with the end in mind. Like if you know that you want to do full-blown 6D maintenance, scheduling, capital planning for the next 50 years, BIM with, that's anchored on a digital twin, then you really are starting on third base because you know what kinds of systems you're going to have to select. You know that they're going to have to play nice in the sandbox with each other. That means looking after, say, an integrated solutions package like one from one of the larger companies in this space like Hexagon or Bentley. Yeah. And they can, if those reps can help guide you through what their packages might look like, but they're always going to be guiding you towards their own software. So it's helpful to have third-party consultants who have experience and relationships with all of those contractors to help you build a composite system that's going to work well together, satisfy all your needs, and not bring a lot of extra, capability that you don't plan to use along for the ride.
Yeah.
So the short answer, which I know people will be grateful for eventually, is planning. You have to plan it, right?
Short answer and the easy answer, but it's the answer.
It's an easy answer to say. It's a much less easy answer to implement.
That's right. How do you measure success with these implementations?
Well, ultimately, it's all about dollars and cents, man.
Yeah.
Like stuff's got to get cheaper, not more expensive. So if you take a construction project that was done the traditional way, the cheapest way, for example, like the planning was done the cheapest way, and it, hits its targets on time, on budget, it's difficult to make a case that it could have gone better, if you had done the digital twin and done 5D BIM or whatever. Like it would be difficult to make that case. Even if it were true, it would be difficult to make the case because the organization got what it wants. So success has to boil down to proving in advance, at least making a convincing case that you can really save some money by doing it this way, because the planning will be more expensive. That's the dirty little secret here. Like, yeah, it's complicated and difficult, time consuming, challenging, and expensive to do change control with 2D drawings, for example. If you're trying to do change control in a 3D space using 2D drawings, like it's two totally dissimilar languages trying to speak to each other. It's difficult to get that right. And change control is traditionally one of the biggest drains on, constructions when they're in execution. So the number one thing you can say is like, success for me looks like cutting change in half or less.
Yep.
Right. Just doing way fewer changes. Right?
Yeah, that's good. Albert, what separates companies that succeed with digital twins from those who fail?
I think it boils down to the planning element I was talking about before. You really have to be devoted to doing a fulsome plan. So I've seen projects that were supposed to have 4D BIM, like a full-blown 4D BIM implementation, get scaled back to doing, we'll do a 3D BIM and then take the BIM part out of it. We're just going to do 3D drawings and then take it out more because, we're going to do 3D models for certain things, So the scaling it back, like basically handicapping your own success is how you can,
Why does that happen?
Fail.
Why?
Because it looks cheaper. Like your average decision maker on your average project. Remembering, by the way, that your average project fails. Okay, like over half of projects fail in some way. They don't meet their targets for cost or schedule, or they don't meet their objectives. The change isn't accepted by the organization. Something will cause it to fail over half the time. That's being generous. It's probably closer to 70 or 80% of projects fail in some way. So that means that your average project leader, like meaning like an executive or a director or something, is probably going to make a bad decision or two. somewhere along the lines. Otherwise, why are the projects failing all the time? One of the classic hallmark bad decisions that project executives love to make is they would rather save $1 today than $2 tomorrow. Mm-hmm. So if you're building 3D models, that takes more effort than building 2D models today.
Yep.
It saves you effort down the road when it comes time to do change control, or better yet, avoid change control. But avoidance is also hard to measure. So if you go through a whole project and there was no change, how can you prove why there was no change?
Right.
So there's some degree of buy-in that has to happen. And that's why I was describing this earlier as like being done by fiat from the ivory tower. Yeah, you need the bottom-up change control piece, like you need the OCM, the culture change. You need all that stuff to be driven through to the. But if the folks that are actually doing the work are all the way bought in and management isn't, then you're going to wind up with, death by 1,000 cuts.
Right. So the companies that are succeeding with digital twins, like, tell us about a couple projects that we found.
When I was doing research for this, I found there was a pretty sharp divide between people who specifically hang their success on a digital twin versus those who are hanging their success on a BIM implementation.
Okay.
So like the digital twin part is often about predictability and maintainability and things like that. So some pretty good examples of that. I also found some pretty wild examples, which we'll get into, but some pretty good examples of that are things like Volvo has a plant in a town I can't pronounce, Umea, I think is what it's called. So the Volvo Group cab plant in Umea has a full-blown digital twin that they use to optimize production processes and shorten lead times. Okay. So they've got a whole page of really neat information about that plant and what they're using it for. Rolls-Royce uses digital twins of their jet engines to predict failure points, improve predictive maintenance programs, and again, shorten lead times for constructing the things in the first place. There's a whole digital twin industry report put together by the Hexagon Group. So Hexagon is one of the software companies I mentioned earlier. They're big in digital twins. They own Leica Geosystems. So Leica Geosystems does GIS and 3D scanning and mapping stuff. They also make those fancy cameras from the 60s that everybody was in love with for a while there. Same Leica. They're now mounting LiDAR pods on
Planes
Boston
and
Dynamics
drones,
robot dogs. Yeah, exactly.
That's another episode. It's pretty cool. Yep.
Yeah, crazy robot dogs, the episode. But yeah, there's that. There's lots of anecdotal evidence that, shifting over to BIM, lots of anecdotal evidence that BIM is saving money on projects. Like I said before, it's difficult to measure. It's difficult to do a root cause analysis on something that didn't happen, right?
Right.
So avoiding change is often an anecdotal story. Like, well, we did a BIM implementation and we saved 30% on cost versus our nearest neighbor project. You get a lot of that. Like, there's a lot of anecdotal evidence that you're saving 30 to 50% on cost. I found a research paper that said the most tangible benefits it was a survey paper. So it went out and looked at a whole bunch of different projects. The most tangible benefits were around communication of design decisions, evaluating change, right? So I can see how that would be a good way of actually accessing that. Well, it's hard to measure the intangible of what didn't happen. You can measure the quality of communication that goes around the design decisions. And it's much, much higher in projects that have implemented at least a 4D BIM model.
So Rolls-Royce, Volvo, they're doing stuff with digital twins. Like, what's some pretty wild, adoption stories, case studies that you found?
Yeah, I mean, you can imagine this kind of...
Take me down the rabbit hole.
Yeah, there's definitely a rabbit hole to be taken down. For sure there is. So the most fun one I found when I was looking into this is there is a digital twin of Singapore.
Of Singapore?
As in the country, Singapore, yes. It's called Virtual Singapore. It was completed in 2022. It is a full-blown 3D model with a lot of information for like city planners and also it's surfaced to tourists in some limited capacity. It's a model of their city, and they keep it updated. They treat it as a true digital twin for, and is this publicly
accessible? Is this, I imagine... No,
I bet if you went looking for it, you could get, because there are like little interfaces you can find where you can get at parts of it, and there's lots of videos and things of it functioning. Yeah. But I wasn't able to find like a download the files here kind of link. So
yes,
that would be
33 petabytes later. Yeah,
Exactly.
Right? I can't imagine how big it must be.
It's a little. It's you get on BitTorrent, and a couple weeks later, you've got virtual Singapore sitting on your
And
desktop.
a ton of viruses. Yep.
And a ton of viruses.
Yeah.
For sure. Australia is working on a very similar project. They're going to do a digital twin of the city of Victoria. So
really?
they're $37 million deep on that one at this point. So
Is
they
that
do
a
have
lot?
big chunks of it built. Well, that's the thing. Like, it kind of isn't. I mean,
Because
for a whole city
you
planning
can't
department.
predict that, can you?
No.
No.
And that's what I was saying earlier. Like, it's really hard to hang a specific benefit on something like this. So you were kind of all, nobody wants to be first to market for anything. Right. It's dangerous to be first to market. You're taking all the risk and hoping that you realize all the benefits of being like a market leader. But when public entities like the government of Singapore or the government of Victoria put their neck out there basically and say, we're going to try this, the rest of us need to be paying attention to see how it goes, right? There's going to be a little bit of advertising going on here, a little bit of marketing, right? About like, oh yeah, of course it's going well. It's been an amazing boon. It's doing this, it's doing that. But you really need to see it shake out in the numbers. Like if in 20 years' time, the cost of, I don't know,
developing a new neighborhood, building
like,
a new road,
did
you
that
can
cost
measure
go down?
in terms of like what is the livability? Like there's some pretty soft
What's
metrics.
Average? How has it changed
I mean,
average commute times? How has it
is the
affected?
community happy? Are they not happy? Like you can measure these things that are loosely correlated to projects that drew their data from those digital twins.
Yeah, you can. And there's a lot of opportunity for further research in those big publicly funded projects along these lines. It's very cool, but it's also really hard to like point at and say, oh yeah, that one was successful.
Yeah.
Like, was virtual Singapore a success? Like, I don't know. I hope so. It's really cool. Like but it's a long-term question with a long-term answer.
What advice would you give to a project manager who's considering, digital twins for the first time with their project?
Well, I would say the digital twin conversation is probably a hard one to have with somebody who's looking to fund a project, because trying to convince them that they should model everything, it might be something you have to work up to. And there's also a lot more and better case study examples about the benefits of BIM versus the benefits of digital twinning. So you start them with the 3D BIM concept, all right, that we can do clash detection. We can do a more efficient routing for spaghetti pipe and conduit. We can do a better job of controlling change down the road by making sure that we've actually thought through the sequencing. So when you start layering the sequencing into that conversation, that gets you to 4D. So, and from there, a lot of large construction projects will integrate their cost and schedule anyway in some way, which means that if you're already integrating your 3D design package with the schedule, you may as well bring cost in for the ride, and that's 5D. And there's nothing stopping you, once you've got a 5D model set up, from tacking on those 6D maintenance elements later. So have the conversation, throw your research on the table, say like, look, planning, a dollar spent in planning is worth $1.50 in construction. All right. So you got to stick to your guns on this being a planning tool that has real tangible benefits to change control. That change control is the most expensive thing that happens, especially if it's during execution. So we can do less of that and make more money at the end of it. Point to all the case studies, say BIM's the way to go. And once you've got a BIM package approved, you can start talking about, well, if we build our BIM package out into a full-blown digital twin and layer on some of the maintenance and upkeep elements to it, not only are we saving money for the 2 or 3 years while the thing's being built, this whole organization can save money for the next 50 years, while the thing's being operated. And that's a powerful statement if you can make it convincingly. So I would say lean on the data, start with the BIM conversation, stair-step it up to as many Ds as you can get, and then start talking about digital twin. Yeah. So that's for projects, I think. That's the way to go.
Great. Well, I'm going to say it one more time, Albert. Thank you
Yeah, yeah.
It's been a fascinating
Now,
conversation.
It has, yeah.
Said before we got on and recorded this how much I love nerding out on this stuff. It's so interesting to talk about, to unpack, and there's so much more of a rabbit hole that we can go down.
There is. We've really just scratched the surface on this. Like, I'm looking at all the research that we didn't use for this episode. Like, there's a whole other episode in here somewhere. So,
yeah, I agree. All right. Well, thanks everybody for listening. I'll see you next time, Albert.
See you, Nate. Thanks again, and we'll chat soon.
Bye, everybody.
Hey everybody, it's Albert here. Thanks for tuning in to the Risky Planner podcast. We hope today's conversation was informative and above all else inspires you to excellence in what you do. If you liked today's episode, don't forget to rate, subscribe, and leave a review. It helps us reach more listeners just like you. I'd also like to thank Thompson Igbo for letting us use his excellent music on our show. If you like what you hear, check him out at igbomusic.com. That's EGBO music.com. Talk at you later.